We've already done the inverse cosine function, so the inverse sine function is very similar. This is a graph of y equals the sine of x, and this is y equals the sine of x reflected over y equals x, which represents the inverse of y equals the sine of x. Notice that this graph is not a function because it does not pass the vertical line test. So let's restrict the domain of y equals the sine of x so that its inverse is a function. That is, so that the function passes the horizontal line test. That is to say, red currently passes the vertical line test, but we need the red graph to also pass the horizontal line test. If it does, then when it's reflected over the line y equals x, blue will pass both the vertical and horizontal line test. So that's what we're after. So there are three criteria. The domain should include the first quadrant or angles between 0 and pi over 2. That's this, and if we include that, we're going to need to get rid of these other portions of the graph. And on the restricted domain, the function should take on values of the range. We need to include one of these half bottom humps. And finally, if possible, let's make it continuous. So if we're starting here, let's choose this one. So it seems to make sense that this is the only interval that satisfies both 2 and 3. So that means we need to remove these other portions of the graph. The three criteria lead to restricting the domain between negative pi over 2 and pi over 2 inclusive, and reflecting y equals sine of x on the restricted domain, that's the red graph, over the line of y equals x results in the graph of the inverse sine function, or y equals the inverse sine of x. So here's a picture with the two side by side. The restricted domain here becomes the range here, and the range here becomes the domain. They both go through 0, 0, but for instance, y equals the sine of x on the restricted domain goes through pi over 2 comma 1. So this function must go through 1 comma pi over 2 and so forth.